Students, welcome to the 38th session of physics class. Myself Latha N, Assistant Professor of Physics, Government First Grade. The learning objective of this unit were already discussed in the session. Topics covered in this session are forced vibrations and condition for resonance. A body vibrates under the influence of some external forces that is called as forced vibrations. If a body vibrates under the influence of some external force, that is called as forced vibration. Consider a body of mass m vibrating in a damping medium. Damping caused by the medium is directly proportional to velocity of the particle. So we know that in the previous session, damping means the decrease in the amplitude of the wave due to the opposition, like air resistance, that is called as damping. So we are considering a body with mass m, and that body is vibrating in damping medium. That means the medium opposes the motion of the object. This damping caused by the medium is proportional to velocity of the particle. The damping produced by the medium is proportional to velocity of the particle, that is given by force due to damping. Since it is always in opposite direction, we have to take minus sign. Fd is equal to minus b into v. Let us call this as equation number 1, where b is called as damping constant, v is the velocity of particle. External periodic force applied to the body is. So since it is a forced vibration, we are applying an external force for the object to move or vibrate. The external force applied on the body is F is equal to F naught e power j omega t. We can represent force in the complex form. So therefore F is equal to F naught e power j omega t, where F naught is the amplitude or magnitude of force and omega is the frequency of the force applied. Then the restoring force acting on the body is, during any kind of simple harmonic motion, the force which opposes the motion, that is called as restoring force. That restoring force on a body is given by Fr is equal to minus k into x. Fr is the restoring force. Restoring force is also opposite to the direction of motion. Hence we take negative sign. Call that as equation number 3. X is the displacement. Here K is called as force constant. When the period of free vibrations coincide with period of force, then it is called as resonance, or the frequency of vibration is coincide with the frequency of the force applied. Then that is called as resonance. In terms of period, we can say when the period of vibration coincides with the period of force, then such condition is called as resonance condition. The net force acting on the particle at resonance is given by, so F is the force applied, that can be represented as m into d square x by dt square is equal to minus kx, that is the restoring force, minus bv is the damping force, plus F naught e power j omega t is the external force applied. All these forces must be equal to period of the force. Therefore, F is equal to the sum of all the forces acting on the body which is under vibration. Then m into d square x by dt square is equal to minus kx minus bv plus f naught e power j omega t. So I am rearranging this m into d square x by dt square. So minus kx ಈ ಕಡೆ ಬಂದ್ರೆ plus kx ಆಯ್ತು. Minus bv equals in ಈ ಕಡೆ ಬಂದ್ರೆ plus bv ಆಯ್ತು, which is equal to f naught e power j omega t. Now substituting v is equal to dx by dt for velocity and dividing whole equation by m, we get d square x by dt square, m by m will get cancelled, plus k divided by m into x plus v divided by m into v is substituted as dx by dt is equal to f naught divided by m e power j omega t. Call this as equation number 4. Now substituting e by m is equal to nu and f naught by m as f and k by m as omega naught square, where nu is called as damping parameter. We have discussed in the last session. Omega naught is the natural frequency of oscillation or vibration of a body. So substituting all these three terms in the equation 4, we will get d square x by dt square plus nu into dx by dt plus omega naught square into x is equal to f into e power j omega t. Call this as equation number 5. Solution of equation 5 is in the form. So this is a second order differential equation. So this kind of second order differential equation is having the solution is of the form of x is equal to a into e power j omega t minus delta, where a is the amplitude of vibration and delta is the phase difference. So the solution for this type of second order differential equation is x is equal to a e power j omega t minus delta, where delta is the phase difference. So now differentiating equation 6 with respect to t, will get dx by dt is equal to j. So this term is in the form of e power ax. So differentiation of e power ax is a into e power ax. Since a is constant, a into j a omega into e power j omega t minus delta. Call this as equation number 7. And again differentiating equation 7 with respect to t, will get d square psi by dt square is equal to j into j square is minus 1, a into, so omega square ಆಗುತ್ತೆ, omega square e power j omega t minus delta. Call this as equation 8. Substituting equation 7 and 8 in equation 5, the second order differential equation, will get the solution like this: minus a into omega square e power j omega t minus delta in place of d square x by dt square plus nu into dx by dt is a omega e power j omega t minus delta, substituted that, plus omega naught square into x is a into e power j omega t minus delta is equal to f into e power j omega t. So here in three terms, common factor is e power j omega t minus delta and also a. Taking common out of e power j omega t minus delta into omega naught square minus omega square, here omega naught square minus omega square. So here A is also common for these two terms, and nu into j a omega is equal to f e power j omega t, dividing by e power j omega t minus delta on both sides. So here e power j omega t minus delta will cancel. In the right hand side, f into e power j omega t divided by e power j omega t minus delta. Then separate ಮಾಡ್ಕೊಂಡಾಗ e power j omega t into e power minus j delta ಆಯಿತು. j omega t e power j omega t ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಉಳಿದಿರೋದು 1 over e power minus j delta ಮೇಲ್ ಹೋದ್ರೆ plus j delta ಆಯಿತು. Therefore omega naught square minus omega square into a plus nu j a omega is equal to f e power j delta. So we know that e power I theta is cos theta plus I sin theta. So here in place of I we have j, and in place of theta we have delta. So this can be written as cos delta plus j sin delta into f is equal to omega naught square minus omega square into a plus nu j a omega. Call this as equation number 9. Comparing real and imaginary parts of 9. In both right hand side and left hand side we have real part as well as imaginary part. Comparing the real and imaginary parts of 9, we'll have omega naught square minus omega square into a is equal to f cos delta. Call this as equation 10. This is the real part, and the imaginary part is nu a omega is equal to f sin delta. That is the imaginary part. Call that as equation number 11. From equation 11, a is equal to, dividing by nu omega, we'll get a is equal to f sin delta by nu omega. Dividing 11 by equation 10, we will get, so here f will get cancelled. Sin theta by cos theta is tan theta. Here a will get cancelled. Nu omega divided by omega naught square minus omega square. Call that as equation number 12. Squaring and adding equation 10 and 11. We have to 10 equation square and square equation 11. Adding the squared values of equation 10 and 11, will get omega naught square minus omega square a whole square will becomes omega naught square minus omega square whole square into a square plus right hand side equation 11, that is nu a omega whole square becomes u square a square omega square, that is equal to squaring of left hand side of equation 10, that is f cos delta whole square will become f square cos square delta plus f sin delta whole square will become square sin square delta. Here in both the terms f square is common, we have to take f square as common outside. Then this term becomes f square into cos square delta plus sin square delta. Cos square theta plus sin square theta is 1. And this term becomes omega naught square minus omega square whole square is into a square plus nu square a square into omega square is equal to f square. Taking a square as common outside, then omega naught square minus omega square whole square plus nu square omega square ಅಷ್ಟೇ ಉಳಿಯುತ್ತಿಲ್ಲಿ. ಇದನ್ನ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ f square ಗೆ, then we get a square is equal to f square divided by omega naught square minus omega square whole square plus square omega square. Then a will be equal to f divided by square root of omega naught square minus omega square whole square plus mu square omega square. Call this as equation 30, and this derivation will be continued. So here A is the amplitude of the force or magnitude of the force. The references for this session are listed. Thank you.